The second most common question I received regarding preparation for exam theory is in regards to a reaction going to completion. So this is how we want to think about it. Imagine you have two reactants. So I have a reactant A and a reactant B. And I want those to react to make possibly C plus D, right? You might have more than that. But the point is, how do I know A plus B are going to react and go to C plus D? So how do I know this even happens? Well, you were given basically 5 choices. So imagine that, let's focus on one of them. So I'm going to focus on D. It doesn't have to be the second one. Let's look at D. Let's look at the properties of D. If D is weak, and when I say weak, I mean weak acid or weak base. So we'll combine those into one point. If D is a weak acid or weak base, then the reaction will happen. And that is because weaks are unreactive or less reactive. So weak things usually form as a product, but they don't unform. They don't go backwards. That doesn't happen. So the reaction goes to completion. So usually what happens is, on this side, you'll have strong acids or base. Strong means they're very reactive. They're going to react to make something weaker. And if that thing is weak, then the reaction will go to completion, meaning that that weak thing is stable. So if you see a weak acid or base in your products, that's a good chance that that reaction is going to go to completion. The second category was if you saw an insoluble salt. So by the way, for number 1, we were talking about aqueous products. If something is aqueous, what you're looking for is it weak? So the weak acids and weak bases, either one of those will be aqueous. So you need to decide what you're seeing. For an insoluble salt, this means you're going to see a solid. So if D, for example, had an S like that, that means you form an insoluble salt. And that will go to completion. And the reason is, if that salt falls out of solution, so if I have A plus B, so everything is aqueous that's reacting, everything's in water at this moment, and I make C plus D, whatever those are. If D is solid, this means it's an insoluble salt. Sometimes you can be told this. You might be told, hey, you have a solid. You already know you're dealing with an insoluble salt. Or sometimes you need to use your solubility rules. So in some cases, you might need to think about, what is the identity of D? Is it soluble or is it not? So if it makes a solid, that is an insoluble salt. That reaction will happen. We've got 2 others to talk about. So if we go to 3, if we form a gas, the reaction will likely go to completion. So if I have A plus B going to C plus D, and if I'm just looking at D right now and I form a gas, then this reaction goes to completion because the gas will escape and bubble away. All right, now the last category is if we form water. Reactions that form water is very unreactive. So if you form water, you make this nice stable solution that's not going to continue on reacting. So for this one, let's say we have hydrogen plus, so we'll put 2 hydrogens plus an oxygen. These are gases. And this will make H2O. We'll make 2 of them to balance it. So this is water. This reaction will happen because we have these reactive portions and we end up making water. So this is an example of one that will happen. So now that we've covered all the basics of the rules and what we're looking at, let's go to one of the examples. Okay, so this is from the practice exam. This is the key and this is my writing. But what I'm going to do is erase it and we're going to start over. We're going to figure out what we're looking at. So what we're going to do for all these reactions, it says look at the equations below. Circle the substance that is produced that causes the reaction to go to completion. So what we're looking at, remember our rules. So what we're looking at for the product, so we're only looking at the products. Do we have water? If we have water, then that reaction goes to completion. So this reaction goes to completion, and the reason is water. So check. All right, do we have any other waters? I don't see any. Okay, so that was one of our rules. The other rules were, do we see any weak acids or bases? Let's do weak acids. We recognize weak acids by looking at molecules that start with an H, other than water, and it's not one of the strongs. So for example, right here, this is acetic acid. It's weak. We know it's weak because, well, we know it's an acid because of the H. We know it's weak because it's not on our list, the strong list. HCl, HBr, HI, nitric, sulfuric, perchloric, perchloric is the F, pardon, is the 3. Some textbooks actually count HClO3. I accidentally wrote it. Not all of them do. Right. So we have perchloric, sulfate, nitrate, hydrochloric, hydrobromic, hydroiodic. These are the classic strongs. So if you see something that starts with an H and doesn't end with these, you know it's weak. All right, so this one, reaction goes to completion because we make a weak acid. And looking through here, I see another weak acid. Here's another molecule that starts with an H and ends with an F. It's not on the list. This also goes to completion because it's a weak acid. Okay, so now Let's look for weak bases. And in fact, there's really only one weak base that we cover in this class, which is, it's written in two ways. Sometimes we write NH3, sometimes we write NH4OH. That's the same thing. So I don't see that anywhere. So we don't see any weak bases. All right. So we've got these. This is our weak category. Let's look for gases. This is hydrogen sulfide gas. This is the smell of rotten eggs. So this goes to completion because there's a gas. Here's our gas. And looking at the others, okay. It's the only one I see right now. And let's do our final category, which is insoluble salts. So which one of these form insoluble salts? Well, if you look at your solubility chart, you have a list of ions that are usually soluble. So for example, just about all nitrates containing ions or ionic compounds are going to be soluble. But most of the time lead is not soluble. So lead is sort of our classic, probably not. So because of this molecule, I can say this is going to go to completion because this makes a solid. So we have an insoluble salt. We can say the same for the next two. Hydroxides are generally insoluble unless they're bound to one of the strong bases. So remember the strong bases. Sodium hydroxide, potassium hydroxide, calcium hydroxide. And you can check your list, but it is on the left side of the periodic table. Magnesium hydroxide is not one of them. So we know that this is insoluble. The strong bases are soluble. That's why they're strong bases. They completely break up to make the ion of the OH minus. This is a strong base. So magnesium hydroxide, if it dissolved, it would be a strong base, but it doesn't dissolve very well. So it doesn't release too much of this hydroxide, so we don't consider it strong. Okay. Most silver salts are insoluble. So we've got another one. Insoluble salt. All right. And as we keep moving along, most hydroxides are insoluble. Again, here's another example. Cadmium hydroxide. It's not one of our strong bases. So I know this is a solid. Right? These are all solids. Insoluble salts. And there's one left. And if you look at your solubility charts, you would see that anytime you see a molecule that has a potassium ion, right, this is the same as K plus Cl minus, those are almost always soluble. So I can label this aqueous. And anytime you see nitrates, it's almost always soluble. So I'll label this aqueous. So because both of my products are aqueous, this reaction doesn't occur. There's no need for it to occur. Remember, aqueous means the ions split up. So this is technically Sp3 plus 3 nitrates. But you get the same thing on the left side. You swapped ions, but this still releases a Sp3 plus. We still have chlorides on both sides. So both sides are the same. So no reaction.